Alright, hey guys, welcome to this session by Great Learning. My name is Anirudh Rao, and in this session we are going to take a look at understanding everything you guys need to know about Python for machine learning. Now if you have tuned into the session, I am sure you know a good deal about Python's popularity and of course the way the machine learning trend is taking over the world, right? So I hope all of you all are excited for this session. Now guys, before we go ahead and begin with this session, let me know, head to the chat box and let me know, type in a quick yes or a no. Type in a quick yes if you can actually hear me fine and if you can see me fine, right? So once you give me a confirmation, we can go ahead and get started with the session, right? So guys, head to the chat box quickly and give me a confirmation. I see a lot of you all tuning in. Dhananjay, Gopala, Michael, Manisha, VR Gamers, guys, welcome to this session, right? So this is going to be a 60-65 minute session and we are going to take a look at, a lot about how you guys can go on to prep, what are some of the skills required and a lot more, right? So Prathamesh says yes, Gopal Krishnan says yes, Michael says yes, and Samriddhi says yes. So guys, superb. Thank you so much for your confirmation. I think we can go ahead by beginning to take a look at the agenda, right? Now, ladies and gentlemen, on this live session, what we are going to take a look at, figuring out is, first of all, we've realized that we're going to be taking a look at Python for machine learning, but you have to understand why Python for machine learning, why not C++, why not Java, or why not anything else, right? So first of all, let's make sure to have a concrete understanding of why Python should be your go-to language for machine learning. Once we're done with that, once you are convinced saying, hey, Python is actually a very good choice, we're going to be taking a look at some of these super important skills that are required, for you guys to actually take a look at understanding and how you can go on to actually start working on your machine learning journey, right? So we're going to take a look at some of these skills. Afterwards, I'm going to be guiding you through these various types of machine learning that we have, right? Supervised learning, unsupervised learning, reinforcement learning. We're going to be taking a look at all of that. I'm going to be giving you real world examples in all of these situations wherever I can, and I promise you that even though you might be a person who has absolutely never heard of Python, who has probably never used machine learning in your life, you could still take away a majority chunk of learning you're going to take away, right? So my point with this session is to make sure to talk to you guys about the importance of Python, how it is used, what should you concentrate on learning, and of course how you can actually get started with this session, right? Alright, we have a lot of people in the comment section. Omkar says, please speak in Hindi. Omkar, this is a session meant to be in the English language, and make sure you're not spamming the comment section, right? Alright, super. Biswajit says, you are great, sir. Well, Biswajit, thank you so much for your kind words. I hope you guys are subscribed to the Great Learning YouTube channel because here we have multiple subject matter experts bringing you their thorough expertise across multiple different domains, right? So guys, if you have subscribed to the channel, head to the chat box right now and type in a quick yes, right? Okay, now while you guys go on to do that, let us get started. Without any further ado, we can get started, but let me check a quick did you know with you guys. Now, first of all, ladies and gentlemen, you should not be surprised when I tell you that Python is the world's most popular programming language today because it is so easy to use. At the end of the day, it finds itself in all the domains, right? When you think about web development, think about game development, think about data science, think about big data, think about data analytics, think about, again, I can just keep telling you all these domain names, and Python is gaining so much traction everywhere that in my opinion, maybe in the next 10 years, it will be the gold standard for a programming language. In fact, if anyone asks me right now, what programming language would you suggest someone to learn? Hands down, I'm going to say Python. And, of course, there are very good choices out there, right? C, C++ are still absolutely powerful, fantastic languages. But when you take a look at how Python has grown, right? For example, did you know how Python was named? People usually think that it's named after a snake, right? Python, the type of snake. Well, Python is actually not named after a snake. It is named after a TV show that the founder, the creator of Python, Guido van Rossum, used to watch. The name of the TV show is called as Monty's Python Flying Circus. Now that's a comedy TV show in the early 1960s, and he just wanted to pay tribute to it, so he named it after that, right? So back in the day, when you take a look at how languages were, it was very complex, right? You had to be an expert in very complex syntax to work on Python. But today, if you know how to work with the English language, you can work with Python. That is how fantastic it is. And this, along with the the super powerful language that it is used by hundreds and thousands of companies around the world, right? When I say thousands of companies, it makes sense, because if you go to LinkedIn, if you go to Indeed.com right now and take a look at the number of openings, just type Python in the job roles, right? You will see thousands of job openings there. So at the end of the day, there's always a constant requirement for Python developers, especially a Python developer in the machine learning community, definitely, right? So a lot of people, a lot of companies who have never tried machine learning before are now coming to life saying, hey, we want to implement machine learning for our products, our services, our apps, or whatever it is. So there is always a role, there is always a job that's created, and of course, since it takes a lot of expertise, the salaries are absolutely fantastic as well, right? Superb, guys. So coming to the first point on the agenda, why you guys should consider learning Python. The biggest reason I can tell you is that it is a purpose-built programming language. From its inception, the newer versions of Python, with every single version, there has been such an improvement, which is basically aligning it in a way where it feels like it is built for that, right? So usually whenever you guys go on to buy clothes or something like that, for some of us at least, you'll feel like having a tailor-made suit, a suit or a tuxedo or something like that fits you really, really well compared to what you would rather buy just off the shelf, right? Think about it. Similarly, Python gives you this feel for machine learning because it has so many libraries, it has so many helpers, so many functions, which at the end of the day will help you actually sit and focus on the logic rather than breaking your head about complex syntax. What does this mean? What does that mean? Absolutely no, right? So guys, you head to the comment section, you tell me, what do you think takes more effort, logic or just writing the syntax, right? Because I know the answer that you guys are gonna give, and having more time to work on the logic and having the ability to say, hey, it's fine if I just figure out the logic, I can write the code, right? That is very important, not just for a simple machine learning algorithm, but especially when you're working with complex models, right? This is really, really important, guys. So at the end of the day, when it's purpose built for something, of course it will be developed in a way such that it goes hand in hand with the current trends that we have. And when you take a look at the current trends as well, right? Everyone wants a programming language which is built for dynamism. When I say dynamism, you are today you're working on a very small project. Since you guys are learners, you might be starting out with a very simple project. Maybe a couple of months from now, you're working on really, really big projects, right? So at that stage, you will not be able to say, hey, it is more difficult to work now. In the case of Python, you'll not be able to say that, because regardless of the complexity of your project, the syntax of Python, the way you are working with Python still remains the same, right? So your complexity will not, your problem complexity will not reflect back into telling you that, hey, Python is making it complex. Absolutely not. That is the biggest advantage why everyone wants to jump on Python, right? And when you take a look at the nature of Python, it's of course an open source programming language, which I think, again, we have to thank the creator of Python, Guido van Rossum. Is an absolute gem of a gentleman, and this programming language that we have so well refined is because of the community effort, right? Thousands and thousands of developers around the world are putting their efforts to actually develop Python for free at the end of the day, to make sure the community has a language to work with. So again, when you start your learning with Python, of course you'll have a question saying, so what is the future trend? Maybe 2 years from now, will there be a language which will overthrow Python, right? No, the development of Python is going on in such a way that, at least in my opinion, I believe that it's future proof at least for the next 5-10 years. There is absolutely no doubt that Python will still hold the top programming language step, because that is Python has been integrated into so many applications and so many domains right now that making a switch for the next 5-10 years is actually difficult, even if there is a language that beats Python, right? So when you're working with Python, you have to understand one thing, right? The functions, the libraries, that is what gives the programming language its power. That is what gives it its strength. And with respect to Python, I know you guys already know this, it comes with a huge library, right? There is a ton of functions, there are a ton of helpers, there are so many libraries, right? So we have a common saying in the world of, in the world of Python development, when you say, hey, I have a problem, I can tell you that in Python, there is a library that will help you solve that problem in an easy manner. So that should be your biggest positive thing to look up to, right? And Python is super popular because it has a very, very large user base, very large community at the end of the day. And this is a superb community unlike anything else that I've seen, right? I'm sure you might have seen Stack Overflow. I'm sure you might have seen all these other websites where people come on to ask for help and eventually, others help them, right? Python is one of the kindest communities where even if a person who has these, you might feel like it's a very silly question that they're asking, but the answers that they get for those questions are so absolutely beautiful that you will feel a passion, you will feel that fire inside you to actually explore more of this, because you know for a fact that if you are stuck anywhere, you can get help easily, right? So that ability while building your arsenal, while building your programming arsenal is very important, right? And when you think about Python as a language itself, how many of you guys have worked with languages such as Java, C or C++? Because their syntax was so complex. If you miss a semicolon, it's an error. You would not figure out what things mean, right? What is stdio? What is conio? What is the meaning of cin? What is the meaning of cout? Right? Unless you're trained to, understand that, as a beginner, as a fresher, you look at it and you will be clueless. But try this out. Take a look at a piece of Python code and I promise you that you can figure out most of the stuff. Of course, it might be difficult for you to understand the logic or whatever, but if you just look at the syntax, you will feel like, hey, this is very easy compared to any other programming language. You guys agree, right? Head to the comments and let me know, because that is what gives Python power. It's all of these tiny things which add up, which eventually not just gives Python its popularity or its community or anything as such. The development is so fast paced, the development is so well aligned for machine learning that at the end of the day, when you feel like, hey, I require a language to learn Python, I require a language to learn machine learning, you will be looking at no other language when you compare it to Python, because again, it just feels like home. It feels like it's built for that purpose, and you will appreciate it as much as I do at the end of this session, I'm sure, right? So coming to a section where we will be discussing about the various skills that are needed for machine learning using Python, right? Now, all of these skills that I'm about to tell you is something you will gain by experience, right? Now, there are certain skills I can tell you, hey guys, start learning Python, do this, do that, start learning functions, start learning for loops. All of those are correct. I know you guys will do all of that, but I'll tell you what, while you're learning itself, if you concentrate on these 4 very important skills that I'm about to tell you, you guys will understand that, hey, from now until probably when you're planning to get a job in Python machine learning, or when you're about to enter the domain itself, right, it will help you 10 times more than just looking at a conventional way of learning, right? So the first thing is, if you are very serious about learning Python for machine learning, let me tell you this. Machine learning works on a lot of data. You require data, in fact, a good amount of data to teach your machine learning algorithms. So in that case, you must be a person who either has a passion for data, or you must be a person who says, hey, I know that data is an entity, and if I go on to, scratch or get deeper into the data, I know for a fact that I can get beautiful insights from it. I can get so many patterns that are hidden in the data. So you really require this approach, and it is understandable as a beginner if you have not worked on this particular approach, right? But working on it and looking at data like your friend throughout this entire process is really going to help you a lot, because it sounds funny, but I find myself talking to data. I'm like, hey, so if I ask you this question, what would my data give me an answer, right? Taking that approach will make it intuitive not only to learn, but to actually gain expertise in a quicker manner, right? Think about it. And The second thing, you guys already know this. Python or machine learning as a domain on its own is extremely popular, right? Very, very, very popular. A machine learning engineer's role is always in the top 3 or the top 4 position in the top 10 careers in the entire 21st century right now, right? It is extremely popular. Now, when it is extremely popular, one advantage is you will get amazing salaries, right? Beautiful, absolutely huge salaries. But what you'll also get is a lot of competition. Think about it. If everyone knows that, of course, this is a market where people are paying you really well and you'll enjoy your job, everyone wants to get into it and everyone are trying, right? Think about it. So what you need to excel in this domain is have an out of the box thinking ability. I'll tell you what, whenever usually someone says, hey, there is a problem I want you to solve, do you think there's only one way you can solve that problem? Maybe as soon as you think about the problem, yes, you'll have that first idea, that first spark. But if you think about it in detail, any problem we have in today's world, there is multiple ways to at least approach it and solve it. You as a person who's willing on Python for machine learning, you really should be thinking about this. How can I approach this in a different way, right? I'm sure you would have heard people say this, think out of the box. In this case, you really don't have to think outside the box or anything as such, but you just have to find a way to approach the problem in a different way that common people would do. I'll tell you what, I'll give you the biggest tip that you'll need for your interviews or something like that. Usually if you're going for a machine learning interview, it is common that the interviewer is going to ask you, probably give you a small problem and say, hey, can you implement a machine learning algorithm for this? Can you create a small model for this or something like that? When you are given such a problem, if you just write one solution, it is actually good. But if you ask the interviewer a question saying, hey, I know 3 ways of how I can solve this, and I can tell you which is the most efficient one, which is the least efficient one, which do you want? Don't you think the interviewer is going to be super impressed with your answer? Because having that kind of an approach, telling them that I will give you a choice about what you need to pick, is very impressive, not just to your interviewer, but your managers, your clients, your project in charges, everyone out there. This skill will help you rapidly grow in the chain of Python for machine learning, right? Third thing is logic building skills, right? The most important thing you guys should be working on is to figure out how you can get that thing to work. For example, if you are trying to implement a machine learning algorithm, rather than chasing the syntax, rather than just reading how you can do it and copy pasting it and implementing it or something like that, figure out why it is used, right? Whenever you're trying to take a look at supervised learning, unsupervised learning or something like that, usually you will learn what it is and why it's required. But what you really should be focusing at the end of the day is how best can you use it to solve what kind of problems, right? If you tend to answer that, trust me, that will take you a long way here, right? These are the critical skills that you require. And one more thing you really have to think about is the ability to scale up, right? Today you'll be working on a really small data set, you'll be working on maybe a very small machine learning algorithm, but as soon as you get into your first job, there's a very good chance you're going to be working on a huge data set with a very big team, working on a real life or an industry grade project or something like that. When that is the case, think about it, right? If you have ramped up yourself by giving yourself multiple challenges and you've worked on programming challenges, you've attacked multiple projects and you've figured things out and you've just bridged that gap that exists between what you've just learned versus how you can use it to the best of your abilities. That skill is again very, very important for this section, right? So guys, we've covered why you have to learn Python. We've also understood to a good amount of degree what are some of these skills which are usually not talked about, right? Whenever you say, hey, what are the skills required, people will tell you the same thing: learn Python, start learning machine learning, do this, do that. But these skills, people will, you might have read it, you might have heard about it, but these skills are the ones that will carry you through the long term. So it is super important that you guys focus on this, right? So, Chiranjeev says, sir, I have a question on machine learning. Chiranjeev, please head to the comment section. Do ask your question. I would love to answer that, right? Anjana says, Julia or Python? Well, Anjana, for the case of machine learning, I definitely would suggest Python, right? It's almost like a match made in heaven, at least in my opinion, that I've been working on Python and machine learning for somewhere around 5-6 years now. So I definitely believe that it should be your go-to language out there, right? All right. Now guys, getting started with machine learning. What is the one thing you have to understand about machine learning at this moment of time? Machine learning as it is a domain which is helping us literally in every single field that we have today. But what you have to also understand is that machine learning is a foundation for artificial intelligence. And do I really have to talk to you guys about the trends or about the future of AI? Because again, every domain that you talk about, it sales, finance, logistics, right, healthcare, whenever you think about any domain, everyone in all of these technical, non-technical domains, whatever it is, everyone wants to achieve some level of AI to their they want to bring some level of AI to their products. When that is the case, if you are very clear with knowing that, hey, this is going to take us to one or two steps closer to that, that is very important for you, right? So at the end of the day, what is machine learning? Machine learning is nothing but programs and algorithms which at the end of the day will help you in a way where it has the ability to learn things on its own. It has the ability to improve on its own, right? So whenever you're writing a program, I am sure you can write a program in 3 different ways. But what you're doing here is you're teaching the machine to understand things on its own. Now you might say, hey Anirudh, I know that machine learning is that you're teaching a computer, but don't you think your computer is already intelligent? Well, the answer to that is debatable, because at the end of the day, you might have the fastest computer in the world in front of you right now, but if you just start diving deep into how it understands stuff, at its most basic level, it understands only 2 things: 0 and 1. That is it, right? It makes a combination. It makes trillions of combinations of zeros and ones to actually, in fact, my computer is doing that right now to show you guys this particular PPT that you're seeing, right? So at the end of the day, yes, it can seem like it is intelligent, but you will, when you start diving into machine learning, is when you will understand, oh, okay, so this is how we need to go on to teach our machine learning algorithm. Because you give it a picture, as soon as it sees a picture, it will not understand. It'll be seeing the picture in terms of numbers, in terms of pixels, in terms of all these values and all of that, right? So you have to have a way of how you can go on to teach these machine learning algorithms. And especially with respect to machine learning, you have multiple types of machine learning, right? It's supervised learning, unsupervised learning, and reinforcement learning. Now I promise you that you have used supervised learning, unsupervised, and in fact even reinforcement learning in your real life. Even though you're not a programmer, even though you might never have used machine learning, you've used these concepts, right? Let me tell you how. Let's start with supervised learning. Now, what happens in supervised learning, ladies and gentlemen? Just look at your screen very closely right now. You'll see pictures of flowers, you'll see pictures of dumbbells, and you'll see a picture of a car. Correct? Now, even if I had masked what these are, right, you'll see that I've written flower, dumbbell, and car. If I had even masked this, if this was not shown on the screen, don't you think you could have guessed what it is you've seen on what it is you're seeing? Why is the case? That is because you have learnt it, right? This is not the only picture of the flower that you have seen in your entire life. This is not the only dumbbell you have seen in your entire life. This is not the only car you have seen in your entire life, right? So for your computer, all of this is absolutely brand new, because at the end of the day, with respect to supervised learning, as the name itself suggests, while teaching your machine learning algorithm, it requires some sort of supervision. Now, what I mean by that is very simple. When you're teaching a machine learning algorithm, especially in the case of supervised learning, you will give it pictures of flowers for it to understand. It will use multiple pictures of flowers to understand what a flower looks like. It will figure out, hey, so a flower has to have petals, it has to have a bud in between, it has to have a stem, maybe it will have a couple of roots, leaves, and all of that, right? So it will see thousands of images of flowers, and it will be like, okay, so this is what a flower looks like. That is supervised learning. But here what you're telling is that, hey, here is a picture of a flower. You are telling it 100% that this is a flower, and it will say, okay, so if this is a flower, let me use this to learn what all the other flowers look like. That, in very simple sense, is supervised learning, ladies and gentlemen, right? So even in your real life, you would have done the same thing when you were learning as a child as well. You would have seen a couple of cars and you realize what a car looks like, right? Now you will not see a bike and you will not mistakenly say that it's a car. I am sure no one of you does that, right? Why? Because your brain is trained, the algorithms in your head have trained in such a way where as soon as it looks at a car, you will not only know it's a car, you can guess what model it is, what color it is, how fast it will go, which countries. So you can find like a ton of different things readily in your head. With respect to supervised learning, we go on to do a very similar thing, right? So there are actually groups. Now when you take a look at machine learning, I told you that machine learning is divided into supervised, machine learning is divided into unsupervised and reinforcement. In supervised itself, we have two divisions called as regression and classification. Now regression is very interesting. Again, I would have promised you use this. If you open up your Google Assistant or Siri right now and say, hey Google, what is the weather like tomorrow morning? Don't you think it will give you an answer? It will give you an answer. It will give you a very, very accurate answer. So with respect to regression, it is a concept where you're taking in values, past values and present values, and you're actually trying to predict what's going to happen in the future, right? Now, you can predict in two ways. One, you can randomly guess, right? I'll tell you that, hey, it's sunny tomorrow in Bangalore. There's a very good chance it will be raining the entire day tomorrow. But if you ask Google the question, it has so much data that it can give you a very, very, very accurate and a calculated guess backed by data saying, hey, tomorrow there's a 70% chance of rain. And you guys might have already observed that it is super accurate, right? So that's regression. Classification also you've used in your real life. Now if I give you a couple of oranges and if I give you a couple of apples, right? So I'm going to mix it up and I'm going to give it to you in a bag. And if I say, hey guys, can you split this by fruit, right? Can you filter this by fruit type? Don't you think you guys can do it? Put all the apples on the left side, put all the oranges on the right side. Now if you get your machine learning algorithm to learn this and to do it, you're using a method of learning called classification there. I'm very simple, right? So if supervised learning is all about you telling the machine, hey, this is what it is, now use this to learn, just like saying that, here's a textbook, learn it and eventually come write an exam. What about unsupervised learning? Now unsupervised learning is absolutely amazing because here you can see that I have the same image of flower, I have the same image of car, I have same image of dumbbell. But here what I'm going to do is I'm going to say, hey, here is an image of a flower, but I'm not telling it that it's a flower. I'm saying, hey, you figure out what it is that you are seeing and you tell me, right? So apart from just giving it the actual inputs, I am not going to be telling it in any sort of fashion. I'm not going to be giving any labels to actually tell what the data is. What it does is it starts learning on its own. It finds a structure. Using its learning, it will know what a dumbbell looks like. Using its learning, it will know what a car looks like. Even though it might not know it's called as a car, but as soon as it sees another picture of a car, it understands, hey, so this is what is going on, right? So that kind of an approach where you're just asking it for the structure, where you're just teaching it the essence and eventually working your way backwards to give you an answer. This way of learning is absolutely amazing in my opinion, guys. And here as well there are two types. Very simple. One, we have something called as clustering. Clustering is again, you've used this, right? So if I give you raw apples and if I give you ready to eat apples, let's say a couple of them are still green, not ripe, a couple of them are super red, ripe and juicy. Now if I say, hey, can you actually categorize this between raw fruit and ripe fruit? Can't you do that? Well, you've done this previously as well, I'm sure, right? When you've gone grocery shopping or something with your with your better halves or parents or something like that, you would have done it. That is literally clustering. And if you get your computer to understand, if you get your machine learning algorithm to understand what characteristics, or in this case we call it features, what features should it look for while doing this comparison or while clustering it in similar groups? Very simple, right? So it's not only that, there's something else called association here. Now association is super fantastic and fancy. Again, you might have not used association directly, but you would have seen it used. Now if you're going to Amazon or any other e-commerce site like that, and if you just say, hey, now I want to buy some pencils. Now what Amazon does, as soon as you add some pencils to your cart, it will actually try to say, hey, people who have bought pencils have also bought a tiny notepad or something like that, so do you want to buy it? Have you guys seen that? What is that? Basically it's their machine learning algorithm, it's basically their artificial intelligence bot telling, hey, so if a person has bought a pen or a paper or something like that, there's a very good chance he or she will buy the other thing, so let's actually have recommendation. Now you might think that, hey, so who will buy that? I came for a pen, I'll only buy a pen. But a company like Amazon makes somewhere around 30-35% of its entire sales, millions and millions of dollars in sales, just by using this concept of association, just by telling people, hey, people who have bought this have also bought that, so do you want to try too? That is it. That is what they're doing, and at the end of the day they are making a ton of revenue doing that, right? So it's a fascinating application put in real world use. Now, supervised learning is done, unsupervised learning is done, but there's something called reinforcement learning. What is reinforcement learning? When you take a look at it, guys, head to the comment section and tell me if you have had pets. Let me know if you have a cat, let me know if you have a dog, because this example will work really well if you have a dog. I'll tell you why. Now, have you ever seen a trainer actually teach a dog, a lot of things, how to sit, how to shake hands and all of that? If you observe very closely, the trainer will actually give a small biscuit. The trainer will give a small treat to the dog, if the dog actually listens to what the trainer says, right? Now, I know some cats do it and some cats will just wag their tail and run away, right? So it doesn't work on cats, but this example works beautifully on dogs. Let's just say we are training the dog to give you a handshake. Now, if you are training it correctly, if a professional trainer is training it, he or she will be giving it a small biscuit. So what the dog thinks is that, hey, if I give a handshake, I will get a biscuit. If I give a handshake, I'll actually get something to eat. I'll get a treat or something like that, right? So the dog is concentrating on, I want that biscuit. I want that treat, right? Now, the trainer will not give the dog a biscuit if it runs away. Now, if you go to a dog and say, hey, can I get a handshake or something? And if the dog just wags its tail and runs away, it is not getting any sort of reward, right? Similarly, here in reinforcement learning, you're training your machine learning algorithm to work towards certain rewards. You will try to tell the machine learning algorithm to say, hey, maximize the number of rewards that you will get. And if ever your learning has gone wrong or something, you will again align yourself such that your rewards will be higher. So in the case of the dog analogy again, if your dog runs away, the trainer will whistle and he'll show the biscuit to it, and the dog comes back saying, oh, okay, now I'm going to get the biscuit, right? And again, he makes it give a handshake, and he'll give the little biscuit while training it as well. So that part is super important, because again, this real world example of how we go on to train these dogs, how we go on to work with these pets, is exactly how reinforcement learning works as well. Now, here in the reinforcement learning, since we're just talking about programs and algorithms, apart from a reward, you will also have some sort of a reprimand. You will have some type of a punishment, so that your machine learning algorithm understands that it is going in the wrong way. In real life, if your dog runs away, all the trainer will do is whistle or show the biscuit or something, but here you cannot show a biscuit, right? So you have one number, a metric, an error rate that will tell, hey, you're moving away from your goal. So getting your machine learning algorithm to actually run towards the goal, to align it, to give it a sense of direction, is what is important here in reinforcement learning, right? Okay, so now we have taken a look at understanding supervised learning, unsupervised learning, and even figured out that we have been using reinforcement learning all of our lives if we have ever had a pet, right? Even if you have not had a pet, you would have seen a lot of cases, right? So if you can think of any other cases, head to the comment section and tell me, right? Now, Anisha says, hey, I am little confused that when we have to start learning AI, I am in the first sem of CS. Well, Anisha, it's a very good question. If you have started your journey into the world of computer science, let me tell you that this is definitely your right time to get started with AI. Now, when you are building to AI, as I already told you at the start of the session, it is very important to understand that machine learning is a foundational concept without which you cannot work towards understanding AI, right? Now, the most common way of achieving AI is by using a concept called as deep learning. Now, how do you think deep learning came about, right? It uses almost all the concepts of machine learning, but it does it on a very different level. So if you do not understand machine learning and directly hunt for that, it'll be very difficult, right? So as I mentioned, while you are starting to learn, I highly strongly suggest you work towards understanding Python, understanding how you can use Python for machine learning. Once you're working on your expertise on machine learning, you will eventually understand how to build up to deep learning, how to build up to neural networks, and eventually working towards AI, right? Superb. I hope that answers your question, Anisha. Now, coming to practical demonstrations that I want to show you guys, right? I told you that we're going to be taking a look at practical demos. Now, ladies and gentlemen, one thing you have to understand with respect to these demos that I'm about to show you, do not concentrate on the syntax. Do not just concentrate about, now I know that some of you all might have not used Python, some of you all might have not used machine learning. So explaining each and every line of code for you will be difficult at the moment, but my entire goal with the programs that I'm about to show you is to tell you, hey guys, listen, with respect to Python, I'm just about to show you how easy it is to work with Python and how easy it is for you guys to create ML algorithms, right? Now, people might think, hey, if I'm working on a machine learning example, I'll have to write hundreds of lines of code. I have had a lot of people ask me this question. They just say, hey, if I have to start learning machine learning, do I have to write 300 lines of code to get a basic example or something? The answer is absolutely not, because I'll show that to you practically to tell you why Python is so easy for machine learning, right? So guys, to explain machine learning, I'm going to be picking up two examples, two algorithms. One is linear regression and the other one is something called KNN. Let me explain what these algorithms are and how they work quickly so that you guys will have some idea, right? So when you think about linear regression, right, I already told you what regression is. Regression is a concept wherein you're trying to model a variable, where you're trying to assess a variable based on all the data that you have. Regression is very common for predicting stuff about what happens in the future, sales data and all of that, right? So you might be thinking right now, okay, so if prediction is everything linear regression is about, why is it so popular? It is so popular because it will give you an answer to find out the cause and effect relationship. So tomorrow if I tell you, hey guys, it will rain here in Bengaluru, how do I tell that? First of all, I need to understand that there are lots of clouds that are coming in which will be an effect of rain. The clouds are the cause, the effect is the rain, correct? So with respect to machine learning, with respect to linear regression, you are actually trying to make a numerical, a mathematical connection between the clouds and the rain to say that, hey, tomorrow the precipitation is this and this, tomorrow the probability of rain is this. So you're not just guessing that it will rain tomorrow, you have data to prove, saying 70% it will rain, correct? Think about that. That is linear regression. And if you have taken a look at any machine learning job out there, people would have asked you saying you require regression. Either you use it or not use it on the job, you need this concept in your skill set, in your arsenal as a machine learning engineer, right? So let me give you a very nice example to showcase how you can use linear regression. Now in this particular case, we're using something called as a Boston housing data set. So with respect to housing data set, it's very common, right? Now think about your area, think about your locality, think about your cities right now. You will realize that in your particular city, there are certain areas where the price of your site, the price of land or the price of a building is very, very high, right? And some other areas it is not so high. Now, why do you think that is the case? What is telling that, hey, this house is worth that much, and what is something else to say that there's another house which is worth something else? There are so many factors to assess the price of a house. First of all, it's the area in which it is there. Second of all, the size of the land that the house is built on. How old is the house? What is the tax that you're paying for the house? How many cars can you park? How many floors are there? How many bedrooms are there, right? How old is the building? Is it brand new or is it like 50 years old? There are so many individual contributions that will tell you this is what the house is worth because of so and so and so, right? Trust me, even things such as how far away is your house from the nearest supermarket, how far away is your house from the airport, how far away is your house from like a school or something will affect the price of the house, correct? Now we know this because we have learnt it. We have read it in multiple newspapers, advertisements or something like that says, hey, this apartment is 3 kilometers from airport. This apartment is 4 kilometers from the nearest supermarket. Something like that. You would have seen all of these things. So your brain has already trained and learnt. But what we're going to do is we're going to take data from this a place called Boston in the United States of America, and basically get our machine learning algorithm to understand and see if it can predict the price of the house correctly based on all the data that it sees, right? So with that, let's quickly jump on to the Jupyter notebook that I have for you guys, wherein we can start working on this right now. Vamshi Reddy has a very beautiful point. He says crime rate. Yes, that's the reason I told you the area also, Vamshi Reddy. Now, if there is an area where there's a ton of crime, do you think the houses there will be valued a lot? No, people will not want to pay a really high price for a house in an area which is shady, which is in the gray area, right? Think about it. So that is also very important for you guys to understand. Now let me zoom in a little. So guys, for all the people who might not know, this is nothing but Google Colab. Google Colab is a fantastic place which is free for you to use. It is basically a Jupyter notebook, and for all the people who have said that, hey, installing Python is difficult, I cannot configure Python, I'm not able to get it to work, you don't have to do anything as such. All you have to do is come to Google Colab, start writing your code, hit run, and your code works. That is how simple it is, right? So one important thing that I want to tell you guys is what we are about to do in a structured manner. Now, there are a couple of libraries here, NumPy, Panda, and sklearn, that we're trying to import. Basically, with this, what we're trying to do is we're trying to bring in these helpers and libraries in Python. NumPy stands for numerical Python. For all the numerical calculations and reasoning tasks that we have to do, NumPy is a beautiful library to work with. And then we have Pandas. Pandas will give us access to this wonderful data structures called as Dataframes. It also has another one called series, but mostly we'll be concentrating on Dataframes. These Dataframes and series data structures will, when you're working on large amounts of data, it will get complex, right? But guess what? With these data structures, you can actually have it in a very, very simple fashion and start working with it really quick and in a structured manner, right? So all we are trying to do is we're importing these libraries, and we are trying to actually import this data set called as housing.csv. Now, if I just run it, it's going to give me an error. It's going to tell me, hey, where is the data set? Right now, the data set is in my computer, but I am doing this on the Google Cloud platform. So all I have to do is import the data set here, right? So I just imported it. It will upload right now. It's a very small data set. So as soon as it uploads, as soon as I hit run again, now it will work fine. And you can take a look at all the details. Of course, I'm just printing the top 10 rows for you guys right now. And as Vamshi said, the crime rate is also super important, right? Hence the first column here, Vamshi Reddy, is the crime rate, because there is no point for you guys to pay a high price if the crime rate is high in that area. Another thing which is very, very important in my opinion is the age of the house, right? So age of the house basically will talk. A brand new house will definitely cost a lot more than a house which was built like 96 years ago or 100 years ago. Of course, unless it's like a castle or something, that still matters, right? You'll find out how many bedrooms there are, what is the tax that is being paid. So there is just a lot of details here which basically tells you why that house is priced that much. Now, our goal here is very simple. We're going to be taking all of this data, each row that you see here, right? Each of these rows basically the details of one house. Now, what we are going to do is we're going to take a look at all this data, feed everything to our machine learning algorithm, and ask it a question saying, hey, can you figure out why this house costs so much, right? Super. That's what we're about to do, and as you can see, it's just the same command again. It will help you print it 10 times, right? Look at the command. I am just using one simple line of code, and it is just showing me what the data set is, right? Now, ladies and gentlemen, one thing you have to know about machine learning is the fact that your data quality and data quantity is super important. So you'll have to pre-process your data in many of these cases. And when I say what pre-process is actually, let me tell you this. If I tell you guys saying, hey guys, what is the price you would have paid on this house? There will always be one or two human errors where instead of writing the price of the house, someone might have written their mobile phone number, right? It will not make sense. Your machine learning algorithm will be will be super confused. It'll be like, what is this, right? It'll not understand why your house is like 10 digits long. Why does it cost so much? So you have to make sure at the end of the day that you're taking a look at understanding if there are any such values. In our case, it can be a character value, right? Now if I say what is the age of the house, it has to be a number, but sometimes instead of a number someone might have written a character. That is all we are just trying to check here, and in my case the data set is sufficiently clean enough so you can get to work with that. Right now the next step is very simple, guys. The next step is where we are trying to assess how the machine learning model will learn. All we are trying to do is telling that, hey, I have a lot of data right now. I'm going to split this data and I'm going to split it in two ways. Why should I split the data? Well, think about your college examination for a moment. When you were in your college or when you were in your school or something, you would have been given a couple of textbooks, couple of notes, or some resources to say, hey, study from this. Later you close all of that, keep it away, come write an examination to test yourself. Correct? Similarly here, if I just give all the data to it, it's almost like you are writing your exam with your textbook right next to you. It will not make sense, correct? You're not learning anything, you're just copy pasting it from here to there. But if I hide a bit of the data and if I make sure that it never has seen that data before, and if I say if I use it later to verify if it has learned something or not, it is basically me giving a little test to the machine learning algorithm to see how well it does, right? So for that purpose, all I'm trying to do is I'm taking that entire data, giving it 70%, 70% for it to train, and 30% for it, I'm going to keep it for testing it later. Okay, so all I did was that, and you see this, right? All I did so much by just 3 lines of code. Now if that is impressive, let me tell you this stage. Now I'm sure you can see these 2 lines, right? The one in green is basically a comment. Let me zoom in more so that you guys can see this better. This part, this one line of code is exactly where your machine learning algorithm is actually training. When you say, hey, do I require 100 lines of code to train? No, the actual line that is helping your machine learning algorithm learn is only one single line, which is basically a process called as model fitting. Model fitting talks about how you can use that algorithm, run the data through the algorithm and create a model out of it, right? So as you can see, I've given it the training data here, and as I told you, right, this is basically me giving you guys a textbook to learn. Now after the textbook, you'll have to write an examination. So this is the line where I say, hey, now that you have learned something, tell me what it is that you have learned. Tell me how much you have learned. Right? So when I do that and when I run this piece of code, my machine learning algorithm has learned, my machine learning algorithm has done its training, and it has also done its testing phase. So what's the next thing that I'm supposed to do? The next thing after all of this is basically me figuring out what is the error rate of the machine learning algorithm, right? Now, to spice things up, I actually have another algorithm that we're going to be taking a look at. It's called KNN algorithm. I'm going to be explaining what the algorithm is and all of that. But just remember this number for now. The error rate, whenever I've given it the Boston housing data for this algorithm, is 5.54. Now, it is almost common thought when you think about it, right? Do you think error should be high or error should be low? Of course, error should be low, right? So remember this number 5.54 because we're gonna be using another very different algorithm on the same exact data, and let us see if it can work better or worse. Because in machine learning, this is the big advantage that you get. You can pick up a lot of different domains. You can pick up a lot of different algorithms to do the same task. Not all the algorithms will work the same way, so your result will vary drastically, right? So we're gonna take a look at what KNN algorithm is now. So basically, guys, KNN stands for K-nearest neighbor algorithm. Now when you say K-nearest neighbor, let me tell you one simple example. If you have to go to your nearest ice cream shop to eat an ice cream, there is one way. The fastest way probably is, let's just say that it is 3 buildings away. What you can do, you can walk straight to the ice cream shop, eat an ice cream, be happy. Now, what are the other ways that you can reach the ice cream shop? I will tell you one absolutely meaningless way, right? Now, let's just say the ice cream shop is in Bengaluru. What I'll do is to get to that ice cream shop, I'm going to take a flight to Delhi. I'm going to chill in Delhi for a while. I'm going to come back from Delhi to Bangalore and directly go to that ice cream shop. Now, do you see that pattern there? It is absolutely unnecessary to do all of that, but that is also a possibility. Of course, no one will do that, I'm very sure, but that is a possibility. You cannot say that that cannot be done. That can be done, just that people don't do it. Similarly, in the case of KNN algorithm, what you do is you take one data point and you find all the neighbors around it, because once you have plotted certain data, the neighbors will actually give the data more meaning. It will tell you what the data has to do, right? Now, I know that it can be slightly complex for you guys to understand. So let me give you an example. Let me give you a very different example right now. Think about this. Let's just say that you're trying to predict if the let's just say you have data about height and weight of a person. That is it. You have height, you have weight. Now you have to use the height and weight to guess if that person is a male or a female in this particular case, right? So what we will do is we will have actual data. For example, you can see this. You can see this on your screen right now, right? I have 7 people's worth of data. I have their heights, I have their weights. I also know their gender. I know if this person is a male or I know if this person is a female. I know it. But what I'm going to do is I'm just going to hide this last column and I'm going to give all this data to my machine learning algorithm and say, hey, figure out if this is a male or a female, right? So what is the best way to do that? The simplest way is to actually create a graph. One you have height, the other one you have weight. Now all these pink color triangles you're seeing are the height and weight of females. Now all these dots that you're seeing, green color dots, are nothing but the height and weight of these male, right? So every single element you see here is a person. Now what I will do is I already have 7 people's worth of data. I'm going to add one more person. Now this one more person I add, I am not telling you if it's a male or I am not telling you if it's a female. So let's plot it on the graph. Look at this blue color tiny square that you're seeing right now. This is the new data that I've given you. Now just look at the graph. Just look at the graph and tell me if you can guess if this is a male or a female. If you can guess that this is male right now, how did you do it? Basically all you saw was, hey, for this height and this weight, there are so many male population around this data, so there's a very good chance that this particular person is also a male, correct? If that blue color dot was somewhere near these near these pink color dots, pink color triangles, you would say, hey, okay, so it's all the nearest data points are actually female, so this has to be a female, correct? It is as simple as this, guys. So whenever you take a look at learning, machine learning, or any of these concepts, you will have to find logical ways of how to figure it out. And once you start understanding the logic behind these algorithms, it is a very easy way of how you can work towards this, right? See, I didn't tell you it's a male or a female. I just plotted it in this point, and as soon as you just saw the graph, no machine learning, you saw the graph and you realize that it's a male. Now what our machine learning algorithm is also going to do that. What it will do is it will just find. Now if I say, hey, find me the 3 nearest neighbors or find me the 5 nearest neighbors, it will basically analyze, okay, so who are these neighbors that this data point is around? The 3 nearest neighbors in this case is basically all male, right? So everyone here is a male. So as soon as my machine learning algorithm sees this, it will tell me, hey, there's a 100% chance that this person is a male. Why? It is not guessing it. It actually has a way to tell me that, and it is saying, hey, so at this weight and height range, there is all male population, so this person might be a male. Of course, it can be an outlier. It can be a female also. But majority, instead of an outlier, the general case is that, hey, this is a male population, right? So this is me checking it with 3 neighbors. What if I check it with 5 neighbors, right? Now this is where things get interesting. There's only 4 male population. So if I check it with respect to 5 neighbors, there is also 1 female neighbor there. Even though the neighbor is very far away, that neighbor is still, we are considering it because we only have 4, we want 5, correct? Now, what will happen? Now, even though your machine learning algorithm is seeing 1 female slot there, it is seeing 4 male versus 1 female, right? So it will understand, okay, so if the nearest neighbors are 4 males and there's only 1 female nearby, which will you pick again, right? It has to say that, hey, there's a higher probability that this is a male population. That is simply how KNN algorithm works, guys. You use one data point and you use all the data around that data point to give it some meaning and to figure out its structure that is hidden in the data. How fascinating, how beautiful is this, right? So you might be wondering, hey, why did you take 3? Why did you take 5? Why did you not take 2? I'll tell you this. We pick this value of k, right? The name says KNearest algorithm. This k that you see is basically a number. One, whenever I say k equal to 1, all you're trying to do is assess with respect to one neighbor. If I say k equal to 5, you're assessing that data point with respect to 5 neighbors. We usually pick up a k value to be odd if our data is having only 2 classes. In my case, what is the 2 class? Male, female, done, correct? Of course, this is a hypothetical example, this is a hypothetical case, but here it's just 2 classes. It is 0, 1, true, false, male, female, correct? Here. That is the reason when we have only 2 classes we're comparing, your algorithm is more efficient if you pick up a value which is odd, okay? Super. Let's quickly go on to take a look at this, but that was an example to help you understand what KNN is. What we are going to do right now is we're going to take the same Boston housing data set and I'm going to be telling you how different it is, right? Now, for the people who look at this code, you'll be like, hey, this is the exact same code we used in linear regression. You're absolutely correct. It is the exact same code that we're going to be using there. Now, the next line, you might be like, hey, even the pre-processing code is exactly the same that we did in linear regression. Again, you're correct. It's exactly the same. You will come at this spot. Here also, again, I'm saying, hey guys, we're going to be splitting the data into 70% for training, 30% for testing. Again, the exact same code that we saw for linear regression as well. So if everything is the same, then what is different? Well, what is different is these 3 lines of code that you see here, where I'm telling, hey, instead of using linear regression, start using KNN algorithm. Consider k equal to 3, as in find your 3 nearest neighbor points, train and eventually test on that data. All of that, right? Right from algorithm selection all the way to training it, testing it is happening in 3 different lines, right? So as soon as I hit play, done. My KNN algorithm has actually learnt it, but you should be asking me a question right now. You must say, hey Anirudh, why did you take k equal to 3? How do you know it will work well for k equal to 3? Why did you not try some other value? Very good question, because that is exactly what I'm going to do right now. I don't know that k equal to 3 will be the correct value. So what I'm going to do is I'm going to train that machine learning algorithm 50 different times, 50 times, right? Since it's a very small demo, it'll do it in a couple of milliseconds. But you can see this error rate is changing for different k values, right? So what is my goal? My goal is to bring the error down. So for which case is your error the lowest? Because as soon as I look at this data, I can tell you that for k equal to 4, the error is lowest, 7.00. For k equal to 3, it is 7.01. Correct? So just by training it for these many cases, basically this is a concept called as hyperparameter tuning, where you're just checking out all the possible cases where you'll find the most efficiency. Now as soon as I looked at it, I'm like, hey, I know that at k equal to 4 my machine learning algorithm is going to perform well, right? It's okay. Since this is a demo, what we're going to do is I'm going to use k equal to 3 as it is, and I'm going to print you an error rate. We already saw that the error rate here was 7.014. Okay, if it is if the error is 7.0 for KNN and if the error is 5.54 for linear regression, which do you think you guys would be using, right? So at the end of the day, one of these algorithms is again training using supervised approach. Another one of these algorithms is actually trying to understand how you can learn with respect to the unsupervised, right? Unsupervised learning, I already told you that you're trying to get the algorithm to find a structure that is present in the data, right? So guys, you saw that it really wasn't a lot of complex syntax that we took a look at. Let me hide all the output here for a second. So let me zoom out a little, and once I zoom out, you'll see that you really don't need 100 lines of code. You don't really need 200, 300 lines of code to work with. At the end of the day, it is very simple. If you if you have trained on a little bit of syntax, all you have to sit and do later is work on the logic, work on understanding how the model works, and you are good to go, right? Okay guys, with this, I know you guys will have more questions. I know you guys will be saying, hey, okay, so now we have a very good understanding of what machine learning is, how it works, why Python, all of that. So where do we go ahead with respect to this learning, right? So one thing I can tell you guys is that machine learning is a very big world. Python is a very big world. So whenever you guys are learning, make sure you have a structured learning approach to go about doing that, right? And I always tell you guys, hey guys, subscribe to the channel, right? Why is that the case? Well, if you are a subscriber, you will be the first one to actually get notified every time we put out a video or every time we have a live session such as this. So you can come in, ask all of your questions out there, get answers to your questions, learn something brand new, and eventually you are, it's a win-win situation, right? Think about it. Now, the way I would have explained machine learning, you will see that it's probably very different from how you would have learned it elsewhere, but having a way of learning like this about how you can find structure, how you can relate something to the real life. Reinforcement learning is how you have trained your dog. Supervised learning is how you yourself have learned what a car looks like or what a flower looks like, right? Think about it. If you just find the best way to learn, all these concepts are simple. People usually tell me, hey, programming is very difficult, learning mathematics is very difficult. It can be difficult if you're probably not learning it right. Maybe there's a different way of how you can approach it, and that way it can become very simple for you guys to learn, right? That is something it's very important for you to learn. It's not just me, it's all the subject matter experts here at Great Learning. We always tend to find the best way that you can relate to while learning to your content, because we're not just teaching you content for the sake of you guys learning it. We are also trying to align your learning to what is required in the industry out there. That gap needs to be bridged, and we're doing our efforts to do that, right? So in case you guys love seeing more of this, guys, do take a second to subscribe to the channel. And you have many places where you can get free content on machine learning and all the other domains. We have Great Learning Academy. Great Learning Academy is a place where you'll get a lot of free certification courses, and you can work on that. You can work on multiple courses and get your certificates of completion absolutely free of cost. We have the Great Learning YouTube channel, which you guys already know. And we also have Great Learning blogs, wherein you guys, if you are a person like me who loves reading, you can also learn for free by reading blogs, right? Now I can tell you one thing. All the free, when I say free education, basically all the stuff is very good. It will give you a superb head start. It will launch you into the domain. It will give you intermediate level of knowledge. But if you are a person like me who says, hey, I want to become a specialist, I want to be a thorough expert in machine learning, right? When that is your case, ladies and gentlemen, when you are looking for expertise, I highly suggest you take a look at a couple of post-graduation programs and specialization programs we have here at Great Learning, because with this I can tell you for a fact that if you're given a program such as an online mentorship driven program which is of 12 months of duration, you guys will be taken from being a complete beginner all the way to ensuring that you guys become experts, of course if you've put in the good amount of work, right? So you can find a lot of details about our programs. You can understand the advantage of you guys taking a look at the programs we have here at Great Learning. You get access to multiple job postings, you get live career mentorship, mock interviews, personalized resume building, LinkedIn reviews, and so much more, right? Since this is an online program, you can learn anywhere at your convenience. You will not only have the top-notch faculties that they'll be teaching you, but you have to also take a look at the certification that you're getting, right? Because in this particular case, let me tell you that you will get 2 certifications, one from the University of Texas at Austin that tells you that, hey, this person has completed the post-graduation program in AI and machine learning, and there's one more certificate from Great Lakes Executive Learning which will also say that you've completed the PG program, right? Think about it. Texas University is ranked number 6 in the entire world for business analytics, and you already know how important AI and ML is for business analytics, right? So with this particular 12-month program, you'll be getting 225 plus hours of learning. You'll be learning more than 9 tools and languages and all that. Right from the foundation, ladies and gentlemen, you can find a lot of details here, right? Right from the foundation all the way to ensuring that you guys attain expertise, and additional modules after you've attained expertise is also something that we are after here, right? And you'll see that with respect to every module, we're giving you multiple quizzes, we're giving you multiple projects that you'll be working with, and at the end of the day you'll also be working on a hands-on project. You'll be working on a capstone project wherein you'll be showing your real world expertise. You'll be telling, hey, this is you'll be telling, hey, this is what okay, sorry about this, hang on. So you'll be saying, hey, this is what I have learned and this is how I have put it to use by solving an industry level problem. Solving an industry level problem in a domain such as this will make the difference from your profile just being good all the way to it being great, right? So guys, that is super important for you to understand. Now, having a certificate, having understanding of all of this is super important for you. But what you also should know is that you will be taught by the faculty. These guys are the leading academicians in this particular field of AI and machine learning. At least in my opinion, they are from top organizations, and these guys thoroughly know what it is that they are doing, right? So they have trained, they have mentored a lot of people over the years, and they will be your faculty for this. And it's not just the faculty, guys. You'll also get mentors who will be along your way of learning, and these guys will absolutely help you. Whenever you're learning from faculties, you also get the advantage of these mentors who will be guiding you through the program as well, right? You can find out multiple testimonials from our learners. You can read a lot of reviews. You can read a lot of feedback and all that. And since this is a 12-month program, right, this is not a 15-day program, guys. This is 12 months, 1 year, and you're getting a postgraduate program certificate as well, right? So of course it has a small fee, and I can tell you myself that it definitely is worth your money. It's worth your time, it's worth your money. You will have so many advantages, not just in terms of learning, but also mentoring, but also access to jobs and a lot more, right? So guys, all you have to do to get more details about this program is I'm sure the person handling the chat right now will give you a link to this program. Just go through the link. You'll find out all the details that is for you guys to know. And what you can do is, at the end, I know that some of you guys might still have doubts, might still have more questions, and you'll be confused about saying, hey, Great Learning provides so many different programs for machine learning itself. Which do I pick? Correct? So just put in your name, your email address, your mobile number, and your work experience, and hit submit. We will have our own experts from our admissions office give you a call for free, and they will guide you out on every single query that you have in terms of what background you come from, which program will help you get to what. They will give you a complete roadmap about what you should do to get from where you are right now to actually get to a point where you're a complete specialist or a complete expert in machine learning, right? Now, and I understand that some of you might be college students. I understand that some of you might have 0 years of work experience. You have just graduated from college. Make sure you're selecting the appropriate option there. If you're a college student, you can select that. If you just graduated, still looking for a job, you can select this. Just depending on your experience, work experience, just put in any of these options, hit submit, and sit back, because in the next 4 hours, our own experts will give you a call, and they will find how best they can guide you, right? So you can find out so many things, guys. You can find out a lot about the success stories as well. You can find out about the 8,000 plus career transitions we have had once people have completed these programs, access to 500 plus hiring partners, and our alumni say that they have an average salary hike of over 48%, right? So you will find a lot of details about all of these on our pages, and of course, right, you can find a lot of details. You can find out our academic collaboration. We collaborate with some of the most fantastic universities in the world, right? Northwestern universities, IIT Madras, IIT Roorkee, PS University, Stanford Business School, a lot more, guys. So you can find all of these details about not just who we are associated with, but all of our hiring partners and a lot more as well. Right? So guys, with this, we have come to the end of the session. I hope with this session, you guys are clear with everything we have covered, right from the basic of why you should learn Python, how you guys can go on to learn Python, all the way to showcasing what machine learning is, the various types of machine learning that you can go on to understand, and eventually showing you demonstrations that, hey, you can solve a same problem. You can take the same data set, solve the same problem using multiple algorithms. I also showed you that, right? So guys, I hope all of you all are clear with everything everything I've guided you through today. If you did enjoy this video, do take a second to like it, and of course subscribe to the Great Learning YouTube channel so that you come across more videos such as this, and you will be the first ones to get notified as soon as we go on to do this, right? Alright guys, as always, you guys are an absolutely amazing audience to teach. You have asked so many questions, and you've had multiple interactions, right? So you guys always keep it highly energetic. You guys are super enthusiastic to learn, which I absolutely love. So right now is the amazing time for you guys to pick up machine learning. Right now is the correct time for you guys to learn Python, and I can assure you that everyone who's watching this live session, you guys can become experts if you use a structured way of learning. And as you would have followed through the session, if you have a different way, if you have a creative way of learning things, you guys can learn anything that's out there, right? All right, guys, with this, you've come to the end of the session. Thank you so much for watching. My name is Anirudh Rao, and I'll see you on the next one. All right, have a beautiful